Yeah, hi. Good evening, everyone. Hello, am I audible?
Yes, you are audible. Good evening.
Okay. Yeah, I am Atul, instructor of not for this course, but yeah, this session is basically for a revision session. We are conducting for quiz 2. So today we have the plan to discuss all mock questions in details. Okay, and we have some additional practice question. If all mock question will be covered, similar practice questions is also there. 11 questions is there. Okay. So as you know that quiz 2 syllabus is mainly week 5 to week 8, and I think 1 week is only programming. So only 3 weeks contents are there. But yeah, also revise the content from week 1 to week 4, because some questions may also be asked from that part. Not in the partial weight, higher weightage. Maybe 5 to 10 marks question may be asked from the week 1 to week 4 also. Okay. So revise the concept of that week 1 to week 4. Okay. Other than this, week 5, 6, and 8. I think week 7 is just a programming part. So we will discuss that mock paper which we have released. So let me share my screen. Okay, so you can also discuss your thinking on the each question. So in this way, we will discuss the questions. Then that will discussion will also be happen to understand the questions or other options also. So I hope my screen is visible and this page is visible to everyone.
The screen is visible, but there is one small issue.
Mm-hmm.
For some reason, the setting where we can, set your screen to the spotlight, that is not appearing. Is that an issue for somebody else also, or just for me?
My shared screen is not visible.
No, the screen is visible. It is just small, as in a tiled format.
It's
So,
small. Okay. So I think you should have one option to just expand the screen, like
yeah, I'm not able to, work that option. That's why I was asking. Fine, fine. I'll see what I can do.
because someone is mentioned, it is fine for me. So full screen I cannot extend because this participant will also be
I know it's
visible.
okay. Wait, I'll just leave and rejoin and see if it helps.
Okay. Okay, someone is asking, sir, what is the syllabus for OPP for Linux? So this is not a Linux course. So Linux syllabus is I think complete syllabus is there. So week 1 to week 9 or 10. Okay, for me as well. Okay, so let's start the questions. So as you know that these mock questions is also a PYQ questions, not just a mock questions. We have just configured this as some PYQ, previous year question paper, as a mock. Okay, so paper questions will be very similar to this type for your quiz exam. Okay, so pattern will be little bit theoretical also, because most of the content are discussed theoretical, and your assignments are also similar to this. So practice on your assignments and PYQ and mock papers, all this you will get a similar type of questions also in the exam. So some memory based question is also there, because that is discussed in details in the lectures. So first question is, which wireless communication protocol is optimized for long range, low power application, and it's commonly used in IoT deployments? So any thoughts from your side for this? What is the correct answer? Do not open the answer, because I think this is configured as a practice assignment. So you can check answer also. But without checking the answer, just tell me what is the answer and why the other answer is not correct. So anyone want to tell me the answer for this? Yeah, Tanjil, you go ahead.
So if I remember, then LoRa is the one that we use for long range and low power, but I don't know
Mhm.
how IoT fits into that.
Okay, so you know that what are the application of IoTs?
No, I don't know much about that. Sorry.
Okay, okay. So IoT basically we also use some wireless sensor network. If you listen that terms, wireless sensor network, where our sensors are located in different locations, and that locations may be far actually from the main devices. So yeah, answer is correct. LoRa long range. This is a wireless communication protocol that provides the communication for like long range, and that takes a low power, because when we are working with the like sensors and some devices, that device is communicating with the all sensors. So like if example, if you're talking about the that wireless sensor network for the agriculture, so our farm may be a large area where we can set up a sensor to just identify the density of that our farm that things. Okay, so how what are the nature that the quality of the that water level, water density, all these things. Like applications are many applications are possible. Similar military also. So military also use this wireless sensor network. They put the sensor in long region and they collect the information from the sensor. But that sensor have some specific battery life. Okay, so that sensor battery cannot be recharged at time to time or daily basis. So that all sensors have some limited battery. So that means they are just collecting some information by some sensors, and they are sending that to the main the devices. Okay, so some may transmitter, some antenna, this receiver, that's uh, things are there in these devices. So communication is happening, but that should be happen with very low power. Okay, otherwise if it will take a high power, and then definitely sensor device will be stopped, and we will not get any information. So that device should actually consume very low power, and that communication should also be happen for the long range, long distance. So that is one very important application and also research area of the internet of things. So where we need to use this type of communication protocol that is working for the long range and with the low power application. Otherwise, the remaining Wi-Fi, Bluetooth, BT, all these are very actually short range communication protocol. So maybe 10 to 100 like this meters only. So that is not the suitable protocol for the this IoT deployments or this type of applications. So long days, this LORA, this is the answer for this first option. Okay, this is the correct one. Okay.
So I think professor has mentioned in the lecture that even in urban areas you can get about 2 to 3 kilometers with LoRa or something.
So that because of that we can set up these of our sensor devices for long range, and they will communicate with the main receiver devices. They will send the information. Mainly, sensors are actually send the information. Okay, they are collecting some information by some sensor, and they send the information to some receiver. So that is the work only for the sensor, and that is the IoT these applications. So other applications are also possible, but this is the main actually we required for some long range and low power. So power should be consumed less, and our communication should be happen for the long range. So that type of protocol is provided by this LoRa long range. Someone raised the hand. Yeah, Nikhil, go ahead. Yeah, Nikhil, you are not audible. Sorry.
Hello,
Huh, Nikhil, yeah, now you are audible.
sir. Where Zigbee used?
No, Zigbee actually also support low power application, but range is small. compared to the
So
LoRa.
where it can be used?
So where actually our communication range is required for the short distance, we can use the
Okay.
Zigbee.
Any
Okay, so
example where it should be used?
any particular example? I cannot remember actually. So, but yeah, the main purpose is the small distance, 10 to 100-meter range is there. Yeah, Sanand, if you have
Okay,
any
sir.
example.
Hello, sir. Professor mentioned that Zigbee is more used in home automation and medical device data collection.
So medical device collection means your communication is happening in with one building, like one where the all hospital is there. So same home auto system is also within some limited area. So as I mentioned that, so 100 to 10-meter range, it's actually is, used. Okay, so that is possible for hospital and home also. Okay,
Okay, sir.
yeah. Okay, next question. That which of the following fields bus protocol is known as used in automotive application, such as engine control units (ECUs)? So, any thoughts on this answer? Anyone answer for this? Okay, someone mentioned Bhavya can CAN. Okay. Yeah, so okay. Yeah, answer is correct. Can. Okay, what is the full form of can? Anyone know?
Controller area network.
Okay, yeah, correct. So yeah, so answer is correct. Controller area network. So that is mainly used for. So this is widely used field bus protocol in automotive application, especially that communication between these ECUs, okay, and other electronics component in vehicle. So mainly this is used for the vehicle. Electric components in vehicle actually, and the communication in between that. Others are actually mainly used for industrial automation. So like this Modbus is used for industrial automation. Uh, okay. So same that device net that is also used for industrial automation, and foundation field bus is also used for industrial automation like oil, gas, and manufacturing. This type of devices. So this CAN protocol is basically a application like engine management, anti-lock braking system in vehicle, airbags, and power train control. So mainly modern vehicle which are coming right now. So that have very that these type of features. Where anti-lock braking system is there, automatic this airbags. You all know about that. So that is the communication. If something is happen on some part of the vehicle, other that communication is happened with the other electronics component of the vehicle, and at the action is happen accordingly. So this is the answer. Controller area network is widely used for this. Okay, so I'm marking the answer so we can recap. Huh. So these two questions basically are memory based. So you have to remember that what type of protocol is used for this. So yeah, definitely for this course you have to remember. Another third question is real-time operation in the context of embedded system means. What is the meaning of real-time operation? The hand or yeah, yes, Anand, go ahead.
Sir, RTOS mean the system must respond within a specific time constraint.
Correct. So real time is not very that we cannot say that is instant happen, but some time actually we set. Suppose if we set like 1 second, that our event should be happen within 1 second. So that means some time constraint we have set. So our task should be complete in the given time constraint. If it is taking more time, then this is not a real time. We will not consider that as a real time operation. So that real time operation is very important in very like suppose if we are launching the rockets, so at that time microseconds is also important. So if any operation failed within the microsecond or something, so that will create a much problem for the operation. So this real-time operation in the context of embedded system means our operation or our system must respond within a specified time constant. And similar to RTOS, you have terms so real-time operating system. So that is the purpose of that real RTOS is similar. So that provide the real-time operations. So yeah, this is correct. Real-time operation. Other option, the system must respond instantly. So this is not a fixed thing. uh, we cannot say what is the time limit. This is not actually mentioned in this statement. So that is not correct. So second option is more relevant. The system must operate at the speed of 1 second. So that is also not correct. That may also be bigger. The system must be faster than typical computer. So yeah, that is also not accurate. Okay, so this is the main definition of this real-time operation in the context of embedded system. So the system must respond within a specified time constant. Okay, and similar type hard real-time is also there. So in that case, so this is the soft. Okay, so there are two types of real-time system actually: soft real-time and hard real-time. There are also two category in this. So soft real-time where we can actually manage some time limitation. So if it is taking little bit more time, so that is not will not create a much problem. But like hard real-time system, basically that may create a big problem. So like airbag deployment in car, if some accident happens, so airbag should be open very quickly. So in that case, that cannot be actually late. Okay, so that will create a very failure of the automation. So this is the one thing. Okay, so let's move to the next. So what is the primary reason? Question number 4. What is the primary reason? Region. Okay, what is the primary region of parallel communication is faster than serial communication? So I think this is straightforward. Parallel communication and serial communication, what is the difference in between? Anyone? You can open your mic. Yeah.
Sir, in parallel communication, we use multiple wires to connect the peripherals and all. And in serial communication, least wires are required, just like in I2C, just like it will take 2 wires or something. So that is the difference. And in parallel communication, it transmits multiple bits simultaneously, sir.
Yeah, correct. So as according to the name parallel communication, so that means data is transferring in the parallel form. So multiple data is transferring in the parallel form. So that means we have multiple bus lines and bits. So our data is transmitted in the bits form. Okay, so as you know, at 0 and 0 1 0 1 like this, high signal, low signal. So that bits are transmitting with the at parallel in the on the multiple lines. So definitely in the so we in the less time our big data will be transmitted because we have the multiple lines and data is transmitting parallelly. And the similar serial communication, that means we have maybe one line or maybe very less line, maybe two line, as you said. So data is transmitting on very few lines, that so definitely it will take more time compared to the parallel communication. So what are the primary reason parallel communication is faster than serial communication? So what is the answer for this? Because it transmit multiple bits simultaneously. Okay, so this is the reason because it is a faster. Otherwise, the other option uses fewer wires. So this is not a correct answer for the question statement because parallel communication use high number of wires compared to the serial. So that is not possible. It requires fewer control signals. Also, that is also not the reason. So parallel communication become faster. It has a fewer timing issue. That is also not valid. So the only option two, it transmit multiple bits at the same time. So that is the valid reason for this. Okay, so next question is what is primary difference between TCP and UDP? So anyone know what is this TCP and UDP? And what is the full form of this? Yeah, please tell.
So, sir, TCP stands for Transmission Control Protocol, and it ensures that the data will transfer to the its destination. And UDP stands for User Datagram Protocol. And sorry, sir, but I don't remember what is the function of UDP.
Okay, yeah, TCP you mentioned correct. Yeah. So user datagram protocol. Next question is also very relevant to this fifth question. So what is the purpose of packet switching like this? So TCP mainly what is the so TCP both are the protocol communication protocol, but TCP transmission control protocol actually that create a connection first actually. Okay, so suppose we are just logging the email, so one secure connection is made first, then our communication happens on the same path. Actually, first step is we are creating a connection, so one specific path will be provided for us our communication, and all our communication will happen on that path. So that is we can say that our like channel is fixed, communication channel is now fixed, and our all data is transmitting through the same channel. So here we are ensuring that our data will be transmit completely correctly. Okay, so that is more reliable. UDP is basically user datagram protocol. That's we not actually create a connections. Uh, we not set the first circuit actually, but our datagram. So mainly packets. We divide our message into a small packets, and all that is packets are actually moves from different path because our network is connecting your I'm just running on my system, so that is connected to the network, and that network have multiple paths to reach on the same another locations. So in the UDP protocol basically our datagram means our packets are our message is divided into the packet, and each packet may use the different path. Okay, and finally all packets reached at the final destination, and after that they arranged into the correct message. So suppose if we have one message and that is divided into four that packet. Okay, and ID is also mentioned on the packet, like packet 1, packet 2, packet 3, packet 4, but all packets will be transfer on different channels, different path. Okay, and finally all will be reached at the final destination, and where all will be uh, combined into one message. Okay, so here there is a chance that if we missed one packet or some loss, if we lost some packets, so that is not reliable, but that is actually also used for where our like we if you are downloading some videos from some server, so in that case we can use this UDP. Okay, so where the our that information is not much like important or something, so all packets may come from the different channels, and you are collecting all the packets at some the final destination. But this is more secure. TCP is the more secure actually. Okay, here connection is set, circuit is fixed, then only transmission is happening. So TCP is used for wireless communication while UDP is used for wire. This is not the example. That is not the correct answer for this. TCP guarantees delivery of packet while UDP does not. Okay. So as I mentioned that TCP actually use one fixed circuits or one fixed path, and all packet transmit only on that path. So that is the guarantee. So all packets will be delivered on the destination, but UDP does not. So maybe at some path, if our network is disconnected, so that packet may be lost. So that is the correct answer. UDP is more reliable than TCP. This is also not correct. TCP is more reliable than UDP. This is the correct one. TCP is faster and has less overhead than UDP. Uh, so we cannot say that TCP is faster because here we are using one fixed channel. So okay, so all packets will be moved in the one sequence way. But UDP all can be moved parallel. Like this is also very similar to the parallel communication. Okay, so that may be reached faster compared to the TCP. Okay, so second option is more relevant for the, as a correct answer for the primary difference between TCP and UDP. So next question is also which of the following best describe packet switching? Okay, so now this is about the packet switching, which we have discussed in the previous questions. So what is the packet? So packet is mainly a method where data is divided into small packets and sent independently. Okay, so this is looking the I think correct one. So other also a method where is dedicated circuit is stabilized between 2 points. So this is the TCP actually. TCP protocol. Dedicated circuit is stabilized. But here we are also asking packet switching. Okay. So packet switching is different thing. So that is the very relevant to the first option. A method used exclusively for wireless networks. This is also not relevant. A method for error detection in network. So this is the different things. Error detection that is happening on the physical layer of the OSI model. Okay, so because if you are sending some packets, so that error checking is also happen, but that is the part of some communications. Okay, not the only the packet switching. So packet switching definition is this one, where the data is divided into small packets and sent independently. Okay. Okay, now comes to the seventh question. What are the final value of AX and BX register after executing the following assembly code steps? Oh my god, some weather. Okay. So you can see this assembly. This is one a assembly code. I think we have also discussed this assembly code little bit in C programming course. And AX and BX are registers name. So we will just follow step by step what is happening from top to down and what value will come into the final AX and that BX. Okay. So move AX 10. So that means AX will contain the 10 value first, BX contain the 20 value first, and then add AX and BX. This operation basically happen. We add AX and BX and store the data into AX. Okay. So this means AX will update by AX plus BX. So that 10 plus 20, that is having 30. And next operation is CX. So CX move CX. Okay. So CX is now become 5 assigned. Now subtract BX and CX. So just subtract the value will be assigned into BX and this is like BX minus CX. Okay, so what is the value of BX? So BX is 20 and CX is 5. So like it become a 15. So now finally what value we have in the AX and BX? So AX is now last updated here and BX is updated here. This one. Okay. So 30 and 15. So this option is correct for this. So this is simple assembly code. You can just follow the steps and you can get the answer. Okay. Now next, eighth. Which of the following best describe the role of interrupt service routine? Okay. So now anyone tell me what is this interrupt service routine and why this is used? What is the purpose of this? Anyone? Hello. Am I audible? Okay. Okay, so that okay, ISR basically as per the name interrupt service routine. This is a special function, okay, that execute when an interrupt occurs. Actually, interrupt is just a signal that indicate that some event is require more attention at that time. Okay, so mainly our that embedded system or microcontroller is performing some task, but at that time some other event actually required more attention at that time, so that should happen first, uh, com- compared to the other event which is actually running. Okay, so that type of things, so that will interrupt the current status and will perform and then leave like this. Okay, so this is the purpose of ISR. Okay, so that is like a hardware event where timer expiration or some data arrival or some communication is happening instantly, and that is important actually. Okay, and so for the software interrupts, if you talk about the software interrupt thing, so some system calls that is required from some part of the system. Okay, so that ISR handle the event and ensure that the system respond appropriately before resuming normal execution. So that is the main purpose of the ISR. So here we are asking the same thing. So what is this? It fetches and decode instruction during normal CPU operation. So this is not the ISR. It is a piece of code executed in response to an interrupt handling specific task related to the interrupt. Okay, it manages the synchronous execution of instruction CPU. It prevents the CPU for executing any instruction. So this second option is more relevant here. So this is just a one signal and that have some specific task. Okay. Uh, hmm. ISR. So it is a piece of code executed in the response of the interrupt. Yeah. So some if interrupt is coming, so that ISR actually this part of the code will execute, will handle the task related to the interrupt. So what type of task is coming by the interrupt? So that will handle by the ISR. Okay. So that is the purpose of this interrupt service routine. Which of the following best describe the role of loader? Okay, so loader and compiler, all these things are related to the compilation process. So that is also we have discussed in C programming when we discussed a little bit about this compilation process. So loader is one of the part here also. Okay. So which of the following
Excuse me.
yeah.
Regarding the previous question, please. You mentioned something about software interrupts and you mentioned system calls in relation to that. System calls, I remember we used to talk about in the context of the Linux OS. So, for example, if we want the process ID of something, then I think we
Yes.
get it through some kind of system call which the kernel handles. Could you just explain
Yes,
the
yes.
idea of software interrupt a little more?
So same resource actually. What resource our system has? So any resource is required some particular that like interrupt that specific like attention. Okay. So in our actually system we have multiple resource, memory and CPU and all these things, some network that network interface devices. All these some resources there. So at that time, if any device wants to communicate with the main kernel or in between some important message like, so like suppose if we are running a laptop system and some heating part is also running that, and at that time our computer is running normally, but some heat sensor is actually, so suppose if our computer heated some is heating computer is heated and cross the limit actually which is set to the computer. So at that time some specific like action is required. That indication will be sent to the kernel or that our operating system that this temperature is limit cross the limit, and some specific action is required by the computer at that time. So that is regarding the software interrupt actually. So some communication is happening with by the system call, that is, and some attention is required at that time. So that is related to the software part, which is handled by the calls between the our kernels that is happen. Okay.
So in some sense, it will be handled only by the kernel or something that is
That
like the
kernels,
kernel.
yeah. So that, yeah, that is related to the totally programming or that software part. Okay, so some communication between the kernel, all these things. Okay.
And in that way, it will be different from our hardware interrupt.
Hardware interrupt is like that we are just providing some input from the some port, and that is requires like we also I think see all this type of program where we are just like pressing some button, and our program is running, but we are pressing some button, and at that time that some interrupt is required some by the ASR, so that some action is required. So that is happen by some event or by the hardware things. Still this system call is mainly more very related to the operating system part, so you should have knowledge of threads or all these things, where the multiple, when we are using multiple operations. Okay, so there are multiple threads are also there in one process, so that is actually very deep area of the operating system, so that you have to explore in deep in the OS actually. Okay, so let's move to the next. Okay, which of the following best describe the role of loader in the context of embedded system? So here, loader, what is the purpose of loader actually? So mainly the loader is responsible for loading the program into a memory, preparing for it for execution. Okay, so that is the main task of the loader. So some other thing is other option that one second, it converts source code into object code. So this is the role of compiler actually. Okay, and so we write the program in some source code using like C or something. So that is first converted into a object code like machine readable code. Okay, so that this step is done by the compiler. And second step is combine object files into a single executable file. So that is also not correct because this is the task of linker. Okay, so we included some like this library, that library we are adding into the program. So library is just a different program. So that is also combined into the main program, and finally we get the one single executable file. So that task is done by that compile that linker process. Okay. So other thing is it places the executable code into memory for execution. Yeah, this is the task for loader actually. It optimize code during compilation. This is the different things. This is just a process of compilation. So like many steps we have discussed in the course, like loop unrolling or this dead code elimination. Okay, so that type of step, how we can optimize the code, how we can remove our additional work actually from the code. Okay, and how we can reduce our time, so by the execution. So that process which is happened by some other techniques which compiler has to improve the efficiency. So loader is best described by this option. It places the executable code into memory for execution. Okay, next huh?
Excuse me.
Yes, yes.
So is this part referring to when we take the code and transfer it to the board from our computer, or is this happening all inside the board, that the code is getting picked up from the storage part and loaded into the memory of the board? Which one is it?
No, executable code into memory. So here memory is the different thing. So mainly our code is remaining in the like permanent memory, fixed memory. But when it executes, it will transfer into a RAM. Okay, so that data is transferred into a RAM memory, which is actually communicate with the processor. So loading means our main data is now transferring to the RAM memory, and that will execute. So in our computer system, if we talk about in computer system, all data are available on our hard device like hard disk. Okay, if you're writing like C program in one file, that is also stored into a hard disk. But when we run the code, so that code is actually converted into a object code and stored into a RAM memory, and then it execute by the processor step by step all things. So loading means we are placing our executable code, okay, not the source code. So executable source code is converted into a that object code or machine code, and that actually loaded into a like RAM memory, and then it is read by the processor step by step. So instruction by instruction that execute. Okay.
So the entire code is already present on, let us say, our STM board, for example. And at the
Huh.
time of execution, we are loading it from the storage area into the RAM, and that is the
Yes.
function of the loader.
Yes. Yes. So
Okay.
executable part basically. Hmm. Okay, so next is what does the linker do in the compilation process? So we have already discussed second option of this question. It combined object file into a uh, single executable file. So maybe we our main code have contained some calls of different files, or maybe some pre-defined files like this stdio.h or this string.h, this type of library. And sometimes we also create a project like where our multiple source file is there and we combine into a one file. So all actually linked, actually linked by this linker in a one single executable file. So that is the task for this linker. So here combine this third option is the same. Combine multiple object files into a single executable file. So that is the task of linker. Okay, so move to the next question 11. So what is the correct sequence of operation in the boot up process of an embedded system? Okay, just now tell me what is the process according to you.
First one, I think.
Okay, load bootloader, initialize hardware, and then load application code, and then start execution. Yeah, looking this is the correct one. So start execution is the last step definitely. So all option have the last step, and before that application should be load. So load bootloader basically it start the actually devices. Okay, so that means if we talk about the simple system computer like, so bootloader is the first program that actually load all initialize the hardware and load the operating system, all these things. That is the first actually steps. So in the after starting this step, that our hardware is actually initialized. So we have the multiple hardware in our embedded system or computer system that is actually initialized. All we know that all we have the drivers for all the hardware. So all actually initialize that what are the hardwares are there and what are the functionality of that hardware. And then this application if so embedded system mainly we have the our code is already loaded on the embedded system, so that will load actually and will run. Okay, so this is the process, or we can say sequence steps boot up process for the embedded system when we turn on like in any embedded system. So that is happening. So first option is the correct one for this. Okay, so next question. Which of the following best describe the role of HAL, hardware abstract layer, in embedded system architecture? So hardware, this HAL, I hope you have used this HAL coding, which is provided by the microcontroller. So main actually, the one is called as a hardware level programming. So or device level. So that is actually we. I'm not sure this term it is discussed or not, but we can also write a code on the hardware level. That means we can directly code on the for memory for registers directly in the C. Okay, but for the abstract layer, so that means one that difficulty level we are hiding by some hardware abstract layer. So that means we are not directly interacting with the hardware by the coding. Now one middle layer is there. So then in middle layer, some function is already predefined and created. We will only use that function, and that function will actually interact with the actual hardware. Okay, so that is actually hardware abstract layer. So user is not directly interacting with the hardware. User is interacting with the help with the middle layer, that is called as a HAL, and that HAL layer is now interacting with the actual hardware of the that your microcontroller or embedded system. So this is the purpose of HAL, and it actually this makes easy to use or easy to like interact with the user. Okay, so now HAL provide lots of ready-made function, and you just use the function, pass the value, and your task will be done. Okay, so that is one type of things. So this is just a middle level and provide the interface between application software and interact with hardware. So first option is looking correct. It provide an interface for application software to interact with hardware. So this is just a interaction with hardware, and on the top of that we are creating some application. So what is our some task? So that we code we will written, but we will use the function which is defined inside this HAL, and that HAL will interact with the main hardware, memory, registers, all these part. Okay, all that another hardware of the embedded system. So this is the role of HAL. Okay. So next is what type of error is typically caused by accessing an array out of its bounds in embedded C programming? So what is the meaning of outs of array out of its bound?
Accessing memory that the array has not been defined to contain, but we are just exceeding the level. So if I have a 4
Yes, yes,
size
right.
array, I am using the 5th or 6th addition, and that is the problem.
So suppose if we have defined the size of array is 10, and index will be from 0 to 9. Okay, so that is the allocated for us in the code when we have declared. But at the runtime, we are accessing out of range for this. So like we are accessing the 11th index, 12th index. So this type of index. So that actually have the memory address also, because we allocated memory is till 9th index, but we are accessing out of that. So maybe your code will run, because it sometimes it will run properly, because if that memory is not used by another part of the computer, so you can access that, but you will get a garbage value on that. But sometimes it may also create a error. Suppose if that memory is allocated for some other program, and that program is using that memory, and you are also trying to access that, at that time this may create a problem. Okay, in that case some error will come. So some errors types is given here: logical error, runtime error, syntax error, compilation error. So here logical error is just a error which is in our logic actually. Okay, so that is the different thing. Syntax error, if we have not written any proper syntax here. Compilation error at the time of compilation, so the process what we are following in the compilation things, so that is that at that time if our uh, code is facing some problem. Okay, but yeah, so this runtime, so runtime error means we are trying to fetching the memory when our program is running actually. Okay, so in that case, so that error will come. So that is this runtime error actually it is called. Okay, a compiler error, if we defined as a compiler error, so syntax error and logical error is very clear by the name. But compiler error actually occurs when the compiler cannot translate the source code into a machine code. Some problems happens during this translation process. So that error is called as a compilation error. Runtime error is when our program is running perfectly, but at that time we are just fetching some outbound of the array or some range. At that time, this runtime error may occur, but sometimes not also. Okay, so you may get the some garbage value at that location. So this type of error comes under the runtime error. Okay, so this 14th question. Now, which of the following is the correct way to define a macro for the value 10 in embedded C? So macro, I think if you remember, we have learned this in the last week of the C programming macros. So how we define the macros? So anyone, which one is the correct syntax for that?
Second one, I think.
Okay, yeah. So second one is the correct one statement for. We write this hash defined. This is called as a preprocessor. Okay, make and preprocessor macro, and we are just defining this value equal to 10, and later we can use this. So this is the correct way to defining any macro in C. Okay, so this
Sorry,
is
that question just reminded me. So for the 13th question, if you want an example of compilation error, let us say I am trying to use a variable which I have not declared previously. So that you will call a compilation error, right?
correct, correct. Because at that time, the compilation process will convert this code into a machine code. At that time, it will find out that it is not declared. The type is not declared, and we are trying to using that variables. So that during the compile the translation process, our compiler will generate this issue problem. But runtime error will come, and when our program will convert actually program will translate into machine code, and machine code will start execution. At that time, that runtime error will come. Okay.
So I think if the problem of the memory is too bad, you will even get something like segmentation fault, core dump, and
That
program will
type of
crash and
yeah, that
something.
type of error may come. So similar for the dynamic programming, no dynamic memory allocation, not dynamic programming, dynamic memory allocation process. If you have allocated the memory, and later you free the memory, still after freeing the memory, and you trying to using the same memory again, so that time this error may also occur because now that memory is free and not allocated to you, and you're trying to access that. So at that time, this error may come, runtime error. Okay, so any error which comes at the runtime, okay, when our code is executing, okay, that is comes under the runtime error, and the error which is comes during the compilation process, that is comes under the compilation. And all these are the steps actually. Syntax error. So syntax error is the first step when our syntax is actually checked, our syntax is proper or not. So maybe if you have written if, and if you miss some brackets or something, so that syntax is not proper. That comes under syntax error. Logical error is totally different, which comes under the logic. Actually, logic is not correct. Okay, so yeah, these are the type of errors we have for the programming. So next question is this 15 one. Let's use the example of a finite state machine FSM for controlling an LED with a single button, and states and events are defined as follows. So here all states are given. So this FSM machine is very similar to your conditional statements. Okay, and conditional statement you can make with the help of if else things, or in the C programming we also use this switch case statements. So if this is the condition, this should be happen. If this is not the condition, another step should be happen. Okay, so this is totally on the conditional statements. So here our states are currently this state of this value. What is the meaning of this? LED is off. State on means LED is on. State blinking means LED is blinking. This is the state actually for the LED. Okay, and events are what type of events we are giving actually for to change the state. So that is event button press. So that means button is pressed. Okay, only one time. Event blink done. So blinking sequence is completed 5 blinks. Okay, so that LED is blinking. Okay, and that LED is blinked 5 times. So one event will generate. So that means event blink is completed. So 5 blink are completed. So one event will generate and some state will be again changed. So now this is the information given and FSM is given. Okay, finite state machine is given, and a question is asked here. In the given FSM concept, what will be the next state if the current state is state of? Okay, and the event button press. Okay, event. So current state is this is the state for LED. Current state is state off, and now we are pressing button. So just what is the correct condition is there. So current state you can see we are using as a variable for the switch, and what value we are getting event button press. So it will check. So current state we are passing state off. Okay, so state off is the first case that will match. Inside this, what is the event? Event is event button press. So that is matched with the first inside this condition. And what is the function for this? Current state will become state on. So case first is actually satisfied, and now our task is done within the case first. So current state will become state on. So this is the only steps. So that state on will be the final state after this process. Okay, so this is just a like dry run on the code. Okay, so next is question number 16. So what type of error occurs due to asynchronous event and the order or in which they occur? Hmm, okay. Hardware syntax error is condition. What type of error occurs due to asynchronous event?
Looks like race condition.
Okay, so what is the meaning of race condition here?
So like I'm pressing a button, and
Mhm.
in response to button, some LED has to turn on. But before that action is fully complete, I'm pressing the button again, giving more input over there. So one step might get skipped, right? The LED state might get skipped because I pressed too quickly before the change even became visible or something.
Yeah, so that is the correct, yeah, correct explanation. So, if I talk about the exact thing, so first thing that happens when the multiple actually multitasking environment is there. So multiple task is performing on the same resource, like this. So that type of occurs a asynchronous event and order in which they occur. Okay. Share this. with proper. Yeah, answer definitely. Answer is not compilation hardware or syntax error. This is all just a code related error. Answer is definitely race condition, but we can define race condition. I'm not able to recall from the operating system. So because this is also a very important topic in the OS concept, and same is actually this embedded system. We also use most of the concept of related to the OS, and that is related to this asynchronous events and order. Actually, what order we are getting. But any particular example?
I think I remember Professor had mentioned about something that,
Mm-hmm.
for example, I don't remember exactly, but I think it was something like there is some LED which will show a problem. So the LED will glow if there is a problem. So some problem happens and it turns the LED on, but then some other thing happens and that turns the LED off. So some flag like thing is there and one thing turns it on, but before you can respond to the first problem, something else comes and turns it off. So that kind of problem, I think, refers to that race condition or something.
Okay. Yeah,
I
this
don't
is
remember
correct.
exactly. I don't remember exactly.
So I'm also not able to recall. Okay, so you can explore this. Definitely, these first three options are not correct. So just recap on the lecture again what professor said. Otherwise, some OS related examples are there on the net. You can explore this, where the easy example is given with this race condition. So that is also similar to things when multiple operations are performing on the same resource and order is not proper maintaining, so that actually generated race condition. Okay, so skip. Let me skip here, but you can explore this little bit. Code right now, I am also not able to recall some good example to explain this. Okay, so next 17th question, using 8N1 protocol at this 9600 bps, how much minimum time will it take to transfer 200 bytes of data? So this 8 and 1 protocol. So what is the meaning of this protocol? How this send the bits? Can anyone tell me how use this protocol bits? So 8 and 1. So the meaning of this protocol basically a 8 bit. Okay, so 8 bit is the data, 8 bit used for the data, and no parity bit, and 1 bit for stop bit, and 1 bit for start bit. Okay, so this protocol basically use this structure uh, for the data transmission. So one start bit as a first bit, then 8 bit as a data, then one stop bit. So total 10 bits is required as a 1 byte. Now we will check that what time is required for the transmitting 1 bit actually. So here this is given here. This is the protocol this that is used as a 9600 bits per second. Okay, so we can calculate the time for 1 second is like that is a 1 upon, so this is time for 1 bit transmission. So 9600, so that is the time. And here after that this is the time for 1 bit. Now because we are sending the data like this 10 bits as a 1 byte. Okay, so in this protocol, so we will just multiply this 10 by 9600, so that is time for 1 byte signal. Okay, so this 1 byte signal, and we have total 200 bytes, so also multiply this with 200. This is 2000 and divide by 9600. So just calculate this. We'll get some time in millisecond, actually, not second. So you will get a time in millisecond. And so let me check what we are getting. Okay, so here we have 2000 divided by 96. So this is the coming. So 20833. So okay, so if we change this into a millisecond, so this will become a this 208. So divide by multiply by this 208.3. Just divide this also by a 1000 for to convert into a millisecond. So this will become a 208.33. So that is the second option. Okay. So this calculation is required for this question. First, we are just writing a protocol structure. Okay, and then time for 1 second, then time for 1 byte. Okay, which contain 10 bit, and then 200 bytes time. Okay, now so next is this. Okay, so this question is I think from initial week. So we have this 3C, and this is 2 right shift. Okay. So 3C, if you convert this into a binary number, so what will be the data? So for 30011, this is correct. And for C, so
1100.
91100, and this is equivalent to 12, correct? Okay. And now this is a right shift. This is a right shift of 2 positions. So that means this is a right shift for 2 position. And that means we will shift all the bits 2 position to the right. So that will become a like this 1 1 will come here as like this, and 1 1, and all will become 0 0 0 here. Okay, so all bits we have shifted to the right 2 times. So now we are getting this is as a first hexadecimal, this is as a second hexadecimal. So this is equivalent to 0 and this is equivalent to F. Okay. So now this is 0F, this one. Okay. So this is the answer for this one. So all these questions are the mock questions. So we have some similar type of questions. So Vendu have actually shared this document also. So here also the questions are very similar to what we have discussed now. So this is the first question. You can also try. So 10, 11 question is also there in this documents. Let's me delete this. Okay. So now tell me, we have discussed the similar type of question. Now you can just tell me the answer for this. What is the primary role of a communication protocol in embedded system? What should be the answer for this? Just read the option and just see what is the most relevant answer. Anyone?
The second one, right?
Okay, others are also confirm this. Yeah, definitely. Also, second is the correct answer for this. So primary role of the communication is reliable and standardized communication between devices. Okay, so that is the one. Other option is definitely not very relevant to this. Increase the clock speed. So this is not relevant to the communications. To provide additional storage, this is totally different. To enhance the graphical user interface, this is also not relevant. Only the B option is very relevant to this. So second question, which of the following best describe the packet switch network? So we have already, I think the same question we have discussed. So stabilized dedicated communication is not a like packet switch network. Uh, so that is comes under a circuit switch network, like circuit network switch. Okay, so this B option is the correct one for this. Divide data into packets and that are routed over a shared network. So we divide our packets into a, and that moves to the different shared network. So second option is the correct one for this question also. Which protocol is used to ensure reliable data transmission in a network by stabilizing a connection and acknowledgement received of data? So we have already done this TCP. The third, so that is stabilized communication, and that only that transmission happen by this. And next question is also we have discussed, why is serial communication often preferred over transmission communication? Okay, so this is a little bit different for the related to that which we have discussed. So why serial communication often preferred over parallel communication? So here very relevant option is D, because it requires fewer wire for this. Okay, it is always faster. We can't say this. Okay, so this is not proper suitable. It is only suitable for short distance communication. That is also not relevant for this. We can also use for long distance. Okay, so but it requires fewer wires definitely. Okay, so we are using less wires, so definitely fewer wires is required. So this is more relevant answer for D. Okay, so this question we have also seen. So let's again solve this. So ax equal to 10, bx equal to 20. Add ax and bx, so ax will become 10 plus 20, 30. Add cx is now 5 and bx is now subtraction. Okay, so bx equal to bx minus cx. Okay, so that is 20 minus 5, 15. Bx and Cx, 20 minus 5, 15. So I think this is the exact same question, no change. So 30 and 15 we are getting. But we don't have this answer. I think we have done Ax 10, Bx 20, Ax add, this is the operation 30, Cx is 5, subtract Bx and Cx. So Bx minus Cx. So Bx is 20 and Cx is 5. I think answer said this should be this. I'm not sure. No answer is matched.
Answer B is actually matched.
CX. Okay. Yeah, sorry. I actually am looking for BX. Yeah, correct one. Okay. So we are looking the answer for AX and BX. Mm, okay, so we are asking CX here. Okay, I missed this. So we are looking the value for AX and CX here, final value. So yeah, CX is not updated. So what we have assigned, that is the final value. And AX is now updated, so that is 30 and 5. Yeah, correct.
So I think if he had put in one option with Cx equal to 15, it's easy to get it wrong.
Yeah, because we have solved a similar type of question. So because of this, we cannot read the first statement. So only small changes there. CX we are asking here. Okay. What is the role of ISR? So already seen, to handle a specific interrupt when it occurs. So that again B option is correct. Why is it important to save and restore the context in an ISR? So okay. So because if any interrupt is coming, definitely we have to stop the previous process, okay, at some particular state. So we have to resume that process once our interrupt, that ISR routine will be, that interrupt task will be completed. So definitely this is B option is more relevant of this, to ensure the main program can resume correctly after the ISR execution. Okay, so because we are running some specific program that should start from that same steps. So B again for this, and this is the similar. Okay, Okay, so this is the same FSM question. What we are asking: which of the following transmissions would occur if the current state is state blinking and event blink done? So state blinking is the state. So current state, state on, state blinking. Okay, so this is the case which matched. Inside this, we have the or condition. Either our button is pressed or our blink is done. So this is actually second condition is true because or operation is there. Any condition is true, overall will be true. So this is matched. Now current state will become state off. So by this event, this will become a current state. So state off will be the answer for this B. So in an embedded system, what is the primary purpose of using a watchdog timer? So this is to manage task scheduling. So no, watchdog timer is just actually like a it actually store the events what is happening so that we store the information if anything wrong happen. So this is just like a log type of things. Uh, to manage task scheduling, definitely not. To detect and recover from software malfunction, to measure execution time of task, to synchronize communication between peripherals. So this is also not correct. To C option to measure execution time of task, this is also not correct. Yeah, so B option is more relevant because the purpose of this is detect and recover from software malfunction. So this is like according to the name actually, it watches the all things what happening and it actually detect if something is wrong happen in the process. If something is wrong happen and some failure is happened, so it recover actually from the previous state. That is the mainly purpose of this watchdog timer. You can also explore this is more in the more details on the lecture. Okay, so which type of error handle techniques is commonly used to detect logical error? Okay, so yeah, logical error and invalid input during development and testing phase. So this type of error we mostly use assertion. Okay, so we check sometimes suppose if we are getting some input and that input number is dividing some value actually. Okay, so suppose in that case we will get a zero division error, but we can check this if our input is not equal to zero. Okay, before applying inside the division. So we use the assertion for that handling actually. So and last question is very similar to that. So same type of
Excuse me.
yes.
What are the other options in question 10? Return codes, okay, fine. That only
Uh-huh.
happens when the program concludes. What about the other two?
Exception handling is just a one feature of try catch actually. That all mostly language provide this exception handling features where we put our code inside the try and if any error is comes so that we actually pass by the exception. So that is one feature of the each programming language, exception handling. Okay, and global flag is also some type of variable where we maintain that value inside that and we check that value if we are getting correct by checking the condition or all input. So this is just like a flag or simple variable type of things that is actually global, and we just check the condition and we validate the inputs or all thing error. Okay, so exception handling is basically try catch things. You can explore this in the programming language if you have seen this in C course. If you have done, try catch thing is available in all language.
The one thing about
So
the return codes I'm remembering,
returns code.
it
Okay, so
reminds me
that is
of
just
what
a
we
part
used
of
to
code.
do.
Okay, so let me just open this exception handling for C. If you see this, what is the structure for this? For C. So you will see sorry, exception hand, not this. So you can see try case. Okay, so we put our code in this try block. Okay, if this actually generate this code will generate some error, any error. Okay, so that is handled by this cache. So we will define that. So our actually when our program is running, that will not crash actually. That is handled by this cache. Okay, so we can define some function on in this part. So if any error is comes, like any type of runtime error, compilation error, any type of error comes, our process will not stop. Suppose if we are running some application, okay, we have some software or application for users, and user are using that application, and sometimes if we are passing some input or some any type of value we are passing, and that input is generating some compile error or runtime error, so at that time application will not crash actually. So that error will be handled by this try cache, this exception handling. So this cache part will actually generate some message actually to you on your application that we are getting this type of situation, but your application will still run. Okay, so that is one exception handling concept in the each programming language is available. Okay, so our program is will not crash and will application will not be crash. That will be handled by this. So we can just display some message to the user that this is happening. Okay, so this is the one try catch things. This is called as a exception handling. And this global flag is also very similar to that some variable where you are maintaining some value like true or false some things, and finally you are checking that true or what type of things you are getting in the global flag. So that is also very code related things, similar to your return code or print something. So how you can handle the errors, you can print the things time to times. So step by step you can print some variables value and you can see all steps are going fine. That is the one type of way to handle or like debug. Okay. So, and this question is very similar. You can try to solve the same way. So 8 and 1 start with 1 stop bit, total 10 bit, and now the same is given, but this time only we are asking the time for 100 bytes. So last question it was 200 and this time only 100. So you can calculate in the similar way and you will get the similar type of answer. So these okay, so this is another question. So this is also very similar. You can solve this. So let me. So F0 is 1111 and 0000. This is the one, and we are just transmitting 4 times. Okay, right shift 4 times. So all this one will come in this position. All initial will become 0 and 1111 like this. Okay, all bits will be shifted to the right 4 times. So again, this will become a 0. So 0 and this is F. Okay, so this is right shift. Yeah, so all these questions which actually Suvendra shared with us, and we have discussed mock. Yeah, so we have this today and similar type practice you can
Excuse
do
me.
with. Yeah,
Uh, in that sheet, you had question number 9, right? The one with the code snippet.
this one.
The one with the
Watchdog.
code above that.
This one.
This one. So
Uh,
looking at this one, if we
uh,
um, if we enter into a state blinking, and
mhm.
then it says there will be an event button press, or there will be blinking will be done. Now, if our second button press is arriving after the blinking is over, then we will actually go to state on, right?
So after you are saying that after this event and next step is event button press, correct?
Right, and the button press is
Uh,
happening after the blinking is complete. So we will go
okay.
at that point to state on, right? Instead of going to off, we will go to on, correct?
No, no. So first step, what is happening is event blinking done. So that what was the current previous state that was state blinking. Okay. So all done. So that current state become state off. Then event is pressed like button press. So then current state is state off. and we are pressing this event button press. So then it will become a state on. Yeah. In this way. So
So
by
the,
first event is generating by event blink done. So this is the one event. So your operation will be performed on this basis of this first event. What is the current state? State blinking. What is the event done? This event done. And your current state will become change, state off. Second event is now happening after this. So that is button press. So now current state is become change. So that is state off. So our switch case statement will again check. And now state is off. Inside this event is button press. So now current state become state on. So this is the final state after these two events. Okay.
but this assumes that we allowed the blinking to get completed. If we pressed in the middle, then the outcome is different.
Okay. So if you are pressing button in between when that state is blinking, so again the same things this event will perform and this will done, because we are checking what is the current state and what after that what event is happening. So current state, you are saying that state is blinking and in between we are pressing button. So now this condition will become true inside this situation. So this state off will done. So LED will turn off at that time. So at a time one event will be performed, not no two event. Okay.
Okay.
Yeah.
And one thing, Linux is written in the C language, right? This is
Yeah.
kind of related to one
Yes.
question
Yes.
below over
Yeah,
there.
most of the operating system is written in the C language because C is very closer to the hardware level language, machine code.
So I see, in the C code, we are always writing int main is our main function. And at the end of that, the last line we are using is return 0.
0. Okay.
And in Linux, I think we use 0, the return code 0, as a reference for knowing whether the program completed successfully or not.
So same thing is the same meaning is for C also. Why we are returning 0? That is the information for operating system that everything is successful. Like this is a message indication for the OS. Yeah. So most of the operating system is written in the C actually, and because of that embedded C, that embedded programming, we also mostly this C programming is used because this is very close to the hardware. We can use this pointer concept. So I'm not sure you have done this device level, that hardware level coding or not. So otherwise, the hardware level coding, you can directly interact with the registers with the help of pointers, all these things. So what is the value of at any particular registers or memory locations? You can directly access and you can modify also it with the help of pointers. Other programming language doesn't have this concept of this pointers. You cannot direct actually access the memory by the memory address. Okay.
Okay.
Yeah. Okay. So I have done. So you can practice with all your assignment, grade assignment, and just revisit, and you can get. So yeah, that's it.
Excuse me, do we have time? I want to ask something regarding the lecture content.
Yeah.
Maybe I'll share my screen and point out to you where I want to ask. Is that okay?
You can share me if I recall that. I'll tell you.
Okay. You can see?
Hmm.
Okay, so in this lecture, the professor has shown at some of the points. I'll just full screen this. Uh, right. In this, he has shown in this code how we have included a lot of .h files. This is the main
Hmm.
.c file he's showing, and all the
Hmm.
main .h he has, and a lot of .header files he has included. Then
Hmm.
later on in the lecture, he shows some examples of some of the .h files, like how the h files are looking and what is inside the h files. Let me see if I can find one of those.
Hmm.
This is .c, sensors.c. Why can't I find a .h? Mm, .h. I just want to ask something about one of these .h files. Where is
Hmm.
it? Here we have a .h file. This is for the
Hmm.
sensors, and what we see here is just the definition of one data type,
Hmm.
and then he is calling some functions. And you
Yeah.
can see that the functions that he has written, void init sensors, for example, is
Hmm.
probably written inside the
Source file.
sensors.c. But
Hmm.
how are we calling sensors.c? For example, I mean, in main.c, we only have,
So in main.c, we are including all header file now.
but how are we reaching the .c file? We are
So
reaching the .h file that is
this
here.
sensor. So maybe Prof have discussed this. Maybe this is not a complete code. I am not sure, Professor, I have run this code or not, because this architecture is basically used for as a project when we are creating multiple source file and header file. And we okay. So let me show you. I have also created this structure in my STM that board QID.
Okay, I'll just stop
Uh-huh.
presenting.
One second. So this structure is very important when we are working with the like device level and we are creating the drivers actually. So let me show you this, and let me show you one project. I have one I have to check actually. STM driver test 2. This is this one. Okay. Source and include, not this one. Does the test nucleo hardware. Is this? Hello, lady, bring the turn push button and test. Let me open this one. Driver. Okay, driver include source. Yeah. So this is the one thing. So let me open. I think the same in this startup driver include source file. Not this. Yeah. Okay. So main C. Let me open this. So this is the driver level coding basically. If you know that we use this GPIO, this type of things, and this is our main function, main.c. And we are adding some driver file like this gpio driver. So how our gpio functions are there, so what are the functions we used for the gpio drivers? So actually header file basically we used for the just defining some things and some prototyping, what function we will use, what is the prototype for the function. So all these things is defined under the header files. So if you see the header file structure for this, so you will get a all like this memory address we have defined, so all mostly macros type of things. So this is that header file for this one okay, so this is the g, this one is the for gpio. So you can see how we have defined the pin and GPIO number, GPIO mode. So I'm not sure you have read the document for this HTM control board, but we have defined for mode for GPIO, and we have set some value for that. So all defining things is happened inside the this header file. Okay, and that actually also include this this is the header file basically. And you can see structure, if we are using any structures, that is also defined. If we are using functions, so that prototype, that function declaration we have done in this header file. And when we are creating any source file for this, so that is actually driver.c. In that file we are actually including this header file. So by default all the declaration is included in this source file. So this is now become a one if you combine this. So this, when we are including this header file into this, so source file is now that header file is also included in this, all declaration is also added in this file. So all function definitions are mentioned in this file, source file. And main file basically we are using this structure, main file we are using this dpo driver.h, and where from we are calling this function. So anywhere in which you can see we are calling this cpio write to output pin. So when this function will call, so automatically this gpio driver is already added into this, and gpio driver contains all that this declaration. Hmm. So you are asking that how we are reaching to the source file.
Right, right. Since we are not including the .c file, how are we getting in there and using a function that is defined in, let us say, sensors.c?
Okay, okay. So definition that system that we have added include H. Okay, so I think we have mentioned that is main.c is this one. Okay, so okay, so that is actually internal process that is linked by settings actually. Uh, this is not linked by. So if you can see we have mentioned this inside the driver. So all this file inside the driver is included and source file. So so that is not happening by including the file from here, but that is including by this drivers. Actually this driver file become this complete driver file become a one executable file, and linking is happen automatically by this included and src file, not by the code. I have done this code, let me recall this. So I first term actually I have done this. Was GPIO main GPIO.h. Yeah, correct. We have not included system call. This is different things. Yes. Here driver.h.
I mean, just to be clear, you understand my question, right?
I understand. So you are saying that main function we are only including this header file. and we are calling the functions of that file, and this is accessible by the c this source file, and we are not including that source file in anywhere.
Right, right.
है ना? Okay, so that is the thing. So this is, I think, handled by this IDE, not as included in gpa.driver.h. Let me quickly go through this in GPA detail. Not edit. Range.h. Okay. So I think this, when we actually run this program and when we just compile this program, so at that time all this actually this including, this is the header file where all the declaration is happening, and this src file, actually all this actually linked by this compilation process by this IDE. So here we have only declared this, but this source file will also be added into this link. So there is no need to call this source file, but automatically this will also be linked into a one file. So what we are saying that we are just creating this project. Main.c is the one main file, and when we will compile this, and one this will be converted into a one executable file, at that time all the drivers files will also be added into that. So in that case this header file function will also, this function definition will also be included in the same code. So that function will be accessible from that. Otherwise this is actually drivers, so we no need to actually call this. So still I have to check this in details, so how this is accessible. Otherwise the same project, because this is a one project, and when we are compiling this, it is converting into a one executable file for the embedded system. So all code actually, all executable machine code actually pass into a one file. At that time all functions are available in one file. If you're calling one function, that will call the definition also. So that is the my assumption based on this IDE. But yeah, this is a possible process by this IDE. But still, I need to check actually how this combination is happening. Okay, so maybe next session we can continue this. I'll also mention this to the team, so they maybe will check.
Because so far my understanding of compilation is that it acts only on my main.c. Right?
No. So this is not a single, actually. This is a project. This is a project where multiple things are there. You can see no on, not only the main file is there. You have lots of other files is also there. So finally, when all the project is converting into a one executable file for the embedded system, so all drivers will also be included. So sometimes if you are supposing using HAL function, so that HAL library is also there included in your that code, and that is at the different library actually. That will not included in your main code. But if you're calling that HAL function, so that library is will also be added in your that project. So how that function is will work, so that will also be included in your one executable file once that project will actually compile. So we are not only converting this only main.c to the executable file. As a project, all the requirements, all the related drivers, all will be actually added into this. Driver is mainly a interacts that middle layer code with the hardware actually. So what type of driver code I have written here. So you can see this driver.h, and this is just like a functions which are interacting with the actual hardware. And in main.c, we are calling only these functions, you can see. So we are not directly interacting with the file. We are only calling the function gpad, what is the value for this, and all values are predefined in the that header file or that source file. Okay, and we are only calling the functions. You can see gpio write to output pin. This function we have created inside the driver. And similar, if you are using HAL, so same this type of function is already created inside the driver of HAL. So that we are only calling that function and we are performing our task. So that HAL driver, that driver file will also be added in your code once the when you will compile and you will upload your code into a embodied in that controller. So that will also be passed to the as a executable. Otherwise, how the compiler will understand if HAL that complete driver file will not be passed? Okay, so that is compiled as a complete project, not only the this main.c file. All related files is also added into this. Because this is
And
not a simple C program or simple C compiler. This is just like a where we are using multiple uh, that source also, multiple hardware also in the microcontroller, and that will also be handled. So related code is also required. Related driver is also required. So all will be passed. Mhm.
and the assumption right now is that uh, the driver.h and the driver.c, the source code, they are getting linked together because of having the
Yes.
same name or something.
So this driver folder is there now. So this driver folder. So this inc included and this src. So this mainly this inc contains the header files, and this src contain the source file related to this drivers. Okay. So this complete driver actually file is will also be linked to your main program. Some setting is also required that I'm not able to recall, but if we want to create this type of drivers, we have to actually also set some setting to include this into in our project actually. Otherwise, this actually exclude also. So there is one option include and exclude. So if we are creating some folder and we are creating some this EINC or SRC file, initially that will be actually exclude. That will not be the part of project. But by some setting, we have to include that into our project. So after including, so that will also become your project part, and that will also be processed in your project. Otherwise, that will not process. So that features is actually comes when you create as a new project, and if you want to create a that totally new driver folder. Otherwise, in the another project, this driver folder is available, but you can see here some different files are there. Okay, but here you can see capital D. This is the by default comes. Okay, so some HAL code. Let me show HAL. This one is the HAL. So one drivers you can see if we are creating the code using HAL, okay, so hardware layer in hardware abstract layer. So by default, this library is added. This is the HAL library where you can see same type of structure is there, INC and SRC. This is not created by me or thing. Okay, this is uh, created by the that this STM company. Okay, uh, for this board. So you can see how many headers files are there for each part actually. RCC, that DMA, all header files are there inside this, and source file is inside this. All source file inside this. So this driver is when we are using our HL code in our main file. So this library is also included in our main file. So this complete driver file. Okay. So in main file we are not adding. So if you see where is the main file, Source main.c. So you can see G inside this function GPIO function HAL GPIO write pin. We are calling this function. So how this function is working, because this is defined inside this driver. Okay. So and initially I think that is added. And this is not added. It's still okay. HAL init. All HAL function is there, but so HL programming by default this driver will be added it actually, because this is from the board company they are providing us. But if you want to create the similar type of driver by your own, you have to create one debug folder. You have to create all this INC and SRC, and you have to include that in your project, and you have to add call this header file in your main program. Then it will work. Okay.
So far what we understand is that the .h and .c files are linked together in some way. How exactly it is linked, that part is not clear. But what we know is that because they are part of the same folder, everything that is inside that folder will get, will get will be accessible to our main function when we call it. How the .h and .c are linked together, that is not clear, but they are linked. That much is
Huh,
certain.
definitely the files are also linked in your main file, and that is the requirement of the project actually, and that is linked by this compilation process of this IDE actually, because this IDE is generating a that file, that ESL some file which is we will upload on the microcontroller. So that is the process by this IDE compilation process. This is not just a one C compilation process. Okay, so here we are creating a project actually. So this is the task done by the IDE.
And if I understood correctly, what you said is that a library will contain both INC and SRC folders. That is what makes up a library, right?
Driver. We are saying that.
Right. Drivers is a library. When we talk of a library, we are talking about both INC and SRC folders. INC will have
Huh.
.h files and
So
SRC will
this
have
is
.c.
this is not a mandatory things. This is just a recommendation. Just create a header file as just for a prototyping or defining macros, all these things, and definition should be done inside the source file. You can also create only source file without creating the header file. That will also work, but this is just a architecture recommendation. Just create a good architecture where you can easily manage all the prototypes. You can understand what are the functions are there. Definitions are in separate file, and prototypes and that some macros and defining value, all these are separate in separate file. So this is just a recommendation to argue. Otherwise, you can do all the things in the one main.c file also, but that will become very unreadable things. You can write complete code, all driver code, all these things into main.c file also, but that is not a proper actually structure, that software architecture. Why we use this software engineering or software architecture, why we learn this actually, some proper rules we follow to create some software, so everyone can easily understand, everyone can easily manage all these things if it is written in proper manner. Okay, so because we have the multiple hardware in our embedded, that microcontroller GPIO, we have communication hardware, we have interrupt hardware separately, so we are creating a separate file for each hardware functionality. So that is actually easily manageable. Instead of this, we will combine all the code into the main.c file, so that will become a one file with approx 1 lakh or 10 lakh lines. So we are just actually breaking into some modules, and that modules are properly structured actually. But this is not a mandatory things. No need to. You can also do the same things in one file also. That is not proper structure.
Okay. One question, please, about the way we include these files. I have seen two ways of including files. One involves using the angle brackets, and another involves just using the quotes. Why is there that difference? Could you please explain?
So that include, like you include this has include is to stdio.h bracket. Na, you are just angle bracket you are talking about.
Yes,
So
yes.
that is
And
some standard. That is some standards library which is created by the developer of programming language. So that is actually included by in this way. Okay, but if we are creating any our library, own library, user defined any our particular library, so that will be added by this another way. So they have separated this including way. Standard library will always be added by this angle brackets greater than or low, that is small sign. But if you are writing something, some header file and source file, you will include like this double quote. So that is just a identification of this is a user library or this is a standard library.
okay.
Okay. Yeah. Okay, then shall we close?
Nobody else has questions?
Sorry.
I was just asking if anybody else has questions.
I'm asking. If no question, then we can close. Okay, then no query, then we can close. Thank you, everyone. Bye. Good
Thank you
night.
for your time. Thank you.